Hey guys, it's Bill from Linden, Tennessee. I'm going to try and talk over the rain, but I got great success. I finally figured out my little issues with this thing, and that little doohickey's flashing right now. That indicates that it's charging. That says red, which indicates that we're in the lower 50% of the state of charge, 80% state of charge. And I just got it plugged in there in the front. That's all buttoned up. And let's show you how this here works. Go ahead and unplug it. Now we come over here to our little key switch. Now that gives us 12 volts to everything. If I had headlights, I could turn them on right now. See how that lights up with my headlights? So I've got 12 volts going to everything, and everything being these two contactors if they need it. That's really the only 12 volt load I have on this thing, but what I can do is I've got my little switch in the down position. That means that the mower motor is off. So if I come up here to my little doohickey right here, this is slowly feeding power to my electric power takeoff, which will one day be attached to this in the back. But since I don't have anything, it's not going to do anything. And this right here right now makes that contactor work. All right, that one. Now if I flip this switch up, that removes the possibility of the power takeoff working and just gives power to the motor. And now if I roll this up, watch the amps. And we're spinning. And now if I flip the switch up, watch the amps. Now we're spinning and we got full blast power going to that mower. So we'd be cutting grass right now if we could. And then you go ahead and turn that off. So that is how that works. And that works pretty great. And then if we go ahead and start it, I'm going to just push the key here. Watch the amps jump up. The amps jump up because the main contactor is now working. I got a little green light over here on my controller. That means if I put it in, let's go in reverse. Put it on reverse and give it a little bit of gas. Well, I mean it, go in reverse. Give it a little bit of gas, as they say. We're moving under our own power. And I put it in whatever gear that is first. Give it a little bit of juice. We're moving under our own power. How great is that? This green and yellow wire. So through this contactor that is on, down this way. Just turn the key off, and that just cuts power to everything. Up here and through the controller. And the better part of coming out here almost every day after work for an hour or so wasn't good, and all of last weekend, all of this weekend up until now, this is through about 3 o'clock on Saturday. This contactor work. Just going through my wiring and figuring out what in the world have I done wrong. And my original wiring diagrams, they were flawed in a few different ways. And let's see. Let's go with this one. So this is my this is going to get kind of technical in wiring. If you don't care to listen to this, that's it. Thanks for watching. We'll see you next time. But this is my I wanted to make a holding circuit so that whenever you turn the key on, the main contactor is not on and the controller is not on. But when you go start, it goes into a holding circuit. So that's what the idea of this here is. Whenever you turn the key off, this would cut power to that holding circuit. But the problem that I was having is, so you turn it on, it would just come on. So power would come in through this way, go into this wire here. It would go over to the 12 volt disconnect. That's just for the DC-DC converter. But it would come up here and it would turn this contactor disconnect relay on. So that would close that circuit there. Now, this main contactor is not on yet, but power was coming through here, up through this pre-charge resistor, down. Enough power bled through this green and yellow wire, came through this contactor, and then made the motor contactor come on. That fed power to the controller, and that was it. Now, it still worked, but I didn't have my start like I wanted. So the way I fixed that was to, instead of trying to put a holding circuit on the main contactor, I put a holding circuit on this controller, the contactor disconnect. And it's kind of hard to see here, but it's basically the same thing. So now you come up here, you put power on, power comes up through around this way, and then just goes to the normally open, or it goes to the common terminal, the number 30 of a just standard Boss relay, just goes there. So it doesn't go anywhere. And if you want this contactor to work, this contact disconnect to work, you go to the start circuit. That sends power up through this way, down through this blue wire, over to this yellow wire, which is on the normally open contact. Then that sends power through the yellow wire to the coil. Now the coil is closed. Power is still coming through this on wire to the terminal 30, but now this contact is closed. So now power is coming through this contact to this one, which is connected to the yellow, which is going up and feeding that coil. So it's just going around in circles. And at the same time, the power is also going to the green to turn the controller on, and it's coming over here to turn this main contactor on. I don't know if that makes any sense to you, but that's how it's working. So normally when you have it on run, power just comes over here, doesn't do anything. Whenever you hit start, the power comes up through here. It goes up to the controller, but we're not interested in that right now. What we're interested in, it comes down here, hits this yellow wire. It goes over to the main contactor also whenever you hit start, but it hits this yellow wire and it energizes this controller disconnect. And then once that's done, this power coming through just run comes through these closed contacts now and feeds the yellow and keeps this contactor closed all the time. And then to turn that off, you just turn the key off, and then that cuts power to this contactor and it shuts off. And by having this green wire not connected in any way to the main cable here, it removes any ability for any backfeeding of power anywhere. Fantastic. Now the way I fix this is for the power takeoff and the mower. I'm not even going to show you the old schematic. It'd be a mess to try and describe. But the situation I was having is that if I wanted to mow the grass and I turned the mower contactor on, because I had them both tied together and the PTO contactor was always grounded, they would both come on. There's no reason to have both of them on. If I'm cutting the grass for an hour or two, there's no reason to have that contactor on. It's just wasting energy. And the other situation I had was my soft start over here. If ever if I had the mower contactor turned off and I wanted to soft start the power takeoff, these two soft start wires, which is this, where are they at? Oh, these two soft start wires here, this brown and black, they were actually tied together. And so if I tried to soft start just the power takeoff, the mower would go. Well, that's no good. But worse than that, if I turned the contactor on for the power takeoff, the power would flow from the battery through the contactor, through this little bitty wire, up over here where they were tied together, back down this way, and it would try and run the motor. And the way I found that out was I was over here trying to figure out what the hell's going on, and this wire would jump. It would jump. As soon as I hit that contactor, this wire would jump. And a property of electricity is anytime you flow current through a conductor, it creates a magnetic field. And when I did that, this sucker would make the magnetic field and it would jump away from this one, which also had current going through it. They would jump apart, and this would get warm, obviously, because we got like 50 amps going through this little bitty wire. So I knew that was no good. So I needed to redo this whole damn thing. I said I wasn't going to talk about this. Turns out I did. So what I ended up doing was I took the permanent ground away from this PTO contactor and ran it up to my switch. My ground for the mower contactor was already at this switch. They're kind of backwards here. The ground on this contactor is on the bottom, but it's on the top up here. But the ground goes up. So what happens is, and then the soft start current, I guess, goes through this override relay. And in normal mode, when this relay is off, I want to operate the mower. There's no reason to have this relay on all the time if I'm cutting grass. So in normal operation, this relay is off. So the soft start comes up through here, goes through the normally closed contact, 86A on a Bosch relay. Normally closed contact comes down here and gives the soft start power to the mower. Once I've ramped that speed up, then I can come over to the power takeoff switch. 12 volts is coming through here. Switch happens, it comes down through here, and it turns on that contactor. Now it also comes down here to the power takeoff contactor, but if we follow the ground in normal operation, this switch is down here, so there's no ground to make that power takeoff turn on. Well, let's say I want to use the power takeoff. Okay, I'll flip this switch up. Now I've given ground to the power takeoff contactor, and whenever I hit the PTO switch, power comes over this way, comes down, 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 comes down here and turns the contactor on. If I want to soft start the power takeoff, I've got this switch flipped up. So that means that I've just given ground to that relay, which means the soft start power can come over. Now this relay is engaged and it'll go up this way, come all the way down and soft start my power takeoff. That's it. It works really fantastic. So I'm happy as hell about that. I did go through some stuff on the way to figuring this out. Turns out this is my first override relay. That's this one up here. This one is, it sucks. Like internally, it sometimes gives power to both of these. Like it doesn't have this normally open, normally closed part. Sometimes it does. I blew out two of my little soft start relays. This is my first ignition switch. This is the one that came on the tractor. This has really crappy connectors inside of it, so sometimes it would work and sometimes it wouldn't, so I had to get a new one of those. And of course, this is my DC-DC that crapped out the first time, which I really don't understand why. One thing that I am missing on the tractor and on this drawing, on my main contactor, where the hell is it? Main contactor right there. I need to have, let's go down here. This is my wiring diagram. I need to have a diode across these contactor windings, because whenever you turn that contactor off and a voltage is induced, a really high voltage is induced, and this diode gets rid of it. Now this is the diode that I had on this contactor when it was in a different tractor at one point, but for some reason it doesn't work with 48 volts anymore. It just craps out. Like, if you put a voltmeter on it, current flows one way but doesn't flow the other way. And if you put it on a 12 volt, if you put it on reversed bias, it'll make a spark, but if you flip it over, it won't do anything. But so it works with 12 volt, doesn't work with 48 volts. So I need to get a 48 volt capable diode, and it says right here which one to get. So that's what I'll do. I'll just order one of those. But sweet, man, that's it. I'm really, really thrilled. This has taken a long time to get this right, but I finally got it, and it's really, really great. Very, very happy about that. I want to go ahead and charge my battery up some more, so let's do that, shall we? Just plug that sucker in right there, come around over here, and we can watch our amps run up as the charger turns on. There we go. 3 amps, 5 amps, 6. It'll go up to about 10 amps. And then this charger will turn off at about 57 volts. Right now we're 53.5, 53.6. Yeah, and this is my wire coming in from the charger here. It goes through this little 30 amp fuse. And that's it. It's fantastic. So I'm thrilled to death about that. If it wasn't raining, I'd probably go ahead and get that back body work and its seat, and I'd go drive around a little bit. I don't have any, well, I wouldn't go drive around. I don't have any oil in the transmission yet because I need to deal with this. I need to figure out how I'm going to do that. I want to have a 2-inch receiver hitch on there. So I may end up just making a new piece of this out of, I don't know, a piece of 1/4-inch steel or something, and then just welding a receiver hitch to the end of it. I haven't decided yet how I'm going to do that, but that needs to be done. Over here on the Cub, it stopped raining. Over here on the Cub, I want to show you what I've got planned for this doohickey here. I drew a little drawing here. I want to get one of those cheapo augers from Harbor Freight. They're like $200. They got a stupid little gas engine in it, but I want to get one of those, get rid of that dumb gas engine, put my electric motor, my extra electric motor that I've got on the mower, mount it on there, and then run my wires to my rear power takeoff. And then I can use this thing for an auger. I think that'd be pretty cool. Yeah, and the way, I don't know if I would have this little part, if I even need this little jog up, I'd have to get the actual part to see. But I may make a sleeve that goes over, I could make a sleeve that goes over this piece, or I could just pull this piece out and have a whole new piece that slides in and, you know, just gets pinned in there. So I don't know how that's going to work, but one of these days, next time I'm at Harbor Freight, I'll go ahead and buy one of those things and get that engine off there and come up with a coupler for my motor and then do that, because I think that'd be pretty cool. We wanted to put a little porch in front of our chicken coop, and that would make it a whole lot easier digging holes for the 4x4s for that. Anywho, that is it for this weekend. No, it's not it for this weekend. Another thing I got done on this Cub is I put all the oh yeah, I had to make this mess here removable, because in order to get underneath it here to get all these little bars installed, they've got roll pins in them. I needed to get this out of the way. I couldn't, that's in the way, so I just drilled and tapped some, well, I took a piece of 3/16 metal and welded it to the bottom of this plate and drilled and tapped into that, and then countersunk these screw heads so that when my little tunnel goes over it, it's flush. But that way I can take these screws out, those screws out, a couple of cables, disconnect a whole bunch of crap, but I can take this whole piece out and get to all those pieces underneath. And I was able to do that, and then I got this connected, so we got all that stuff working. I went ahead and connected it to the mower deck to make sure that it does work, and it does. These doohickeys here are bent. This one's kind of bent a little bit, maybe 1/4 inch that way, and this one's bent maybe 1/4 inch that way, so I need to unbend that a little bit so that the rear part of the mule drive sits in the middle where it's supposed to. I need a replacement idler here, but these turn free. The belt that I just happen to have is the right size belt, but I need to rebuild these spindles. I need to sandblast this whole thing and paint it, and yeah, and I need to go up to the front of the mule drive, and I need to kind of clean up all that mess, clean up all that, get these pulleys working right, and get this here situation smooth, and get a correct adjuster here. But yeah, that works great, and so I'm thrilled to death about that. And the belt that I happen to have, that one is the correct size belt. The one that I bought is not the correct size belt, so I gotta take that back. But I'm thrilled to death about how this came along. It's been a really good weekend. Finally, perseverance pays off, and I got something that works. So, for real this time. Thanks for watching. We'll see you next time.